welcome to today's class. And today, before we move to our lesson proper, we have a question which says, why do we refine crude oil? Why do we refine crude oil? If you have listened to, or if you have seen our previous videos, that is crude oil, on the topic crude oil precisely, we talked about how it is gotten, where you get them from, then the formation, down to the exploration and extraction, and the rest and their uses. But now we are at the question, why do we refine crude oil? Okay, when you just get your crude oil, when you extract them, do you just start to use them immediately? Is there any need for you to refine them? Okay, so we are going to get to understand why we refine our crude oil in the course of this lesson. That will lead us to our topic today, which is crude oil refining. Crude oil refining, that is the refining of crude oil. And so at the end of today's lesson, you should be able to discuss the process of refining crude oil. That is the processes involved in crude oil refining. You should be able to discuss fractional distillation of crude oil. In fact, the fractional distillation of crude oil is an essential part, is an essential process in refining crude oil. So you should be able to discuss what happened during this process. You should be able to discuss them and also list the multinational companies involved in crude oil refining. Is it just that anyone will just wake up one morning and say, I want to refine crude oil, there's crude oil at my backyard, they have drilled it, or there's a pipeline going through? Because I remember in the previous class I said you can either transport your crude oil from the extraction site to the refinery site by either using your truck, pipelines, or some other mode of transportation. So maybe you just wake up one morning. Is it that somebody just wake up and say, okay, they found crude oil at the back of my house, or a pipeline passed through the back of my house, let me just go there and take some more and just know who are the people responsible for the refining of crude oil. So refining crude oil is a complex process that involves multiple stages to transform the raw material into various useful products. Yes, every raw material must go through refining process so that you can get the useful part of it. Same thing with our crude oil. It's in its raw form, in its crude form. So you have to refine it for you to be able to get its various useful products. It has, if you've seen the last video, you see the various products that you can get from crude oil, ranging from your cosmetic to your body creams to your raincoats, that is your clothes, the clothes you wear, to lubricating oil. So it is the process of refining crude oil that is where you get all these useful products. So refining crude oil involves three main stages. So when you want to refine crude oil, it involves three main stages, which are: the first one is separation, and it is through distillation. The second is conversion. So after you separated them into their various components, you convert. And during this process of conversion, we have cracking and reforming. And we also have purification. After you've converted, you've separated them into their various components and they are converted, you purify it to remove every form of impurities, so that in the course of using them, you won't have issues with them. So let's look at this. Let's explore these three main primary stages of crude oil. So this occurs through the process of fractional distillation, that is separating our crude oil into their various components. It occurs through the process of fractional distillation. So we are going to look at fractional distillation process, the process involved in fractional distillation. The first one you have there is heating. So our crude oil is heated in a large furnace to vaporize it. You take it to a large furnace where it is heated and it is being vaporized. The temperature is carefully controlled. So you control the temperature carefully, starting at the bottom of the fractional column with higher temperatures and gradually decreasing towards the top. So after you eat, the next thing is fractionating column. So the vaporized crude oil enters a top fractionating column. Once you eat it, it moves, it helps it to move, and it enters the vaporized crude oil will now enter into a third fractionating column, which is a vertical tower packed with a series of horizontal trays. You can see in our picture there, you can see a vertical column, fractionating column, and it's vertical. And when you packed it with your material, that is your crude oil, and you start eating, it start rising, the vapor start rising through it, and each of them is packed into various horizontal trays. You can see 1, 2, 3, 4, and each of them at a particular temperature. So the column is cooler at the top and hotter at the bottom. Then what happens next is vaporizing and condensation. As the vapor rises through the column, the various hydrocarbon compounds condense at different heights depending on their boiling points. Do not forget that I said earlier on that your separation will only take place. It's taking place based on we are taking advantage of their different boiling points to separate them. So our various hydrocarbon compounds, they condense at different heights based on their boiling point, and the higher the top of the fractionating tube of a fractionating column is cooler, while the bottom of a fractionating column is very hot. The lighter compounds such as natural gas and gasoline, when you are talking about gasoline, we are talking about your petrol here, have lower boiling points, and they condense at higher points in the column. That is the higher point. If you can see the picture very well here, you will see 20 degrees centigrade, you see, and so they condense there at the higher points of that fractionating column. Then heavier compounds like your diesel and lubricating oils have higher boiling points, and they condense at lower points. And after that is collection. Do not forget that there are various trays at the end of each column. At the edge of this column, there are various, that's the horizontal column, there are various trays there to collect your condense. That is the condensation that you had, the various compounds that has condensed at those various columns. So your tray is used to collect them. The condensed hydrocarbon compounds are collected at different levels of the fractionating column. Each tray in the column collects a fraction of the vapor that has condensed, and those fractions that are collected are collected based on their boiling points. So you will not have your diesel where you're supposed to have your kerosene. You will not have your naphtha where you're supposed to have your petrol. No, because those trays are placed based on their boiling point to collect each of those components. So the fractions collected include gases, gasoline, kerosene, your diesel, the lubricating oil, and heavier residue, among others. These collected fractions are then further processed in subsequent stages to produce specific products. But before we look at this in the subsequent stages to produce specific product, you're going to look at this picture very quickly. You will see that at the top of your fractionating column, you have your refinery gas at 20 degrees centigrade. So you're going to collect your refinery gas, your gas at 20 degrees centigrade. That is such gas that we use at home, a cooking gas. So you get it at 20 degrees centigrade in your fractionating column, and followed by your petroleum. You see you get it at 70 degrees centigrade. So that tray leading out, that tube leading out of that particular boiling point, it's for petrol. And next on that, you find your naphtha collected at 120 degrees centigrade. That is some chemicals that we use, poisonous chemicals. Then the next is your kerosene. So your kerosene is dense, more dense than your petrol, it's more dense than your gas, it's more dense than your naphtha. So after that, you have your kerosene, which you collect at 170 degrees centigrade. You know, kerosene we use it for cooking too in some stoves and some other usage. Also, you have, after that, you have your diesel. Also, your kerosene is used in your jet fuel. We use it also in the production of ATF in your jet fuel. If you have seen the previous class, you're going to see when I talked about jet fuel, your ATF. So also after this, you have your diesel. That is you get it at the boiling point of 270 degrees centigrade. And diesels are used in heavy trucks. They are used in buses. They are used in our trains, because they have more density, they have more energy. They produce more energy for such heavy duty vehicles than our petrol. And also you have after that you have your lubricating oil, the oil we use to lubricate our engines. So you have them, and you have your lubricating oil, your waxes and polishes, you have them, then followed by your fuel oil, that fuel for ships, for fractions and central heat. You're going to have them here. You're going to have them here, and after that you have your bitumen. Your bitumen, that is for road constructions and roofing. You're going to have them. So the boiling points is the determinant. The various trays are placed at specific boiling point to collect specific products, and you have seen them in the picture. So fractional distillation products, as I've explained, the first one you have is gases, the lightest fractions such as your methane, your ethane, your propane, butane, and all the other families of the hydrocarbons. They are collected at the top of the column as gases. Those ones are collected there. And you have your gasoline next, that is your petroleum. Your petroleum, that is the next fraction, consists of gasoline, which is used as fuel for automobile. That's your petrol. When we're talking about gasoline, I know in Nigeria we call it petrol. So we're talking about petrol here, and that is what you collect next after your gases for our automobiles, such as the car, the buses. Some of the buses use it. So some buses use petrol, that is gasoline, and also some engines too. They use, like our generator, they use gasoline, they use petroleum. The next you have is your kerosene in the fractionating tube. Your kerosene, commonly used as jet fuel and for heating, is obtained at a slightly higher level in the column. And if you look at the diagram very well, you see it at 200 degrees centigrade. Then you have your diesel. Diesel is a heavy fuel, and it is used by heavy machineries such as your train and some buses and heavy truck duties. They all use diesel. So diesel fuel used in diesel engines and heavy machineries is collected at a lower level. Then you have your lubricating oil coming after. Further down the column, heavier fractions like lubricating oil and grease are obtained. So you obtain your lubricating oil and grease at lower column, at the down of the column, then followed by your residue like the asphalt that we use for our road. At the bottom of the column, the heaviest and least volatile fractions known as residue or asphalt are collected. And if you're going to see, if you look at the picture very well, you will see that it's at nothing less than 600 degrees, greater than 600 degrees centigrade. So it's at a very high temperature. So these compounds that are found there, they are less volatile. They are less volatile. Okay, when we mean volatile, that means they disappear. When we talk about something being volatile, they disappear easily. Like your petroleum, if you buy your petrol and you don't cork it, you don't cover it, you open it down, before you know it has disappeared from you come back and you see that it has reduced. And one of those days you will come back, you see that there's nothing there again. It's because it's volatile. It can easily leave, it can easily disappear. So, but these ones that are found at, same thing with your cooking gas. If you open it down and you don't cork it, you see that it has gone. But all these other ones that are found at the bottom of the fractionating column, they are least volatile. They don't easily disappear. They don't easily go out. If you open it down, they least disappear, like your bitumen. So your asphalt, I meant to say, they don't disappear easily. So after the separation, I told us that the refining process takes 3 stages. We have the separation, which is majorly carried out through the fractional distillation process, after which we have the conversion. So this is, of course, you have 2 processes, that's cracking and reforming. After the separation stage, some fractions obtained from the distillation may still require further processing to create more valuable product. So you will not just say, yes, I know that at this particular temperature I'm going to get my petrol, and once I just get it, I'll start using. No, you still pass them through some conversion, that is cracking and reforming, so for it to be more valuable, to give us more valuable product. This second stage, known as conversion, involves 2 main processes. The first process is cracking. Cracking. Cracking breaks down long hydrocarbon chains into shorter ones by subjecting them to high temperatures and pressure. So after you get your petrol, or you get your gasoline, or you get your diesel, or you get your kerosene, that is your jet fuel, and all that's your lubricating oil, you still pass them through another process. And this process, cracking just simply means breaking down long hydrocarbon chains into shorter ones. So how do you do this? To subject them to high temperature and pressures. This process produces lighter fractions such as gasoline by breaking apart heavy hydrocarbons. Then the next is reforming. That is the other part of your conversion. Cracking and reforming. After cracking, what next? Reforming is a process that rearranges. Cracking is breaking down of longer hydrocarbon chains. You can have them in 20s and 40s and their hundreds. So you break them down to a lower one, to shorter chains. After breaking them, you now rearrange. That is what reforming is. You rearrange the molecular structure of the hydrocarbon compounds to produce higher octane gasoline or other valuable products. It enhances the quality and performance characteristics of the fractions obtained from cracking or distillation. So it helps to produce, it gives us higher quality, it gives us good performance, like performance characteristics of the fractions obtained from cracking or distillation. And the third one we have is purification. I don't know if there have come anytime you heard a story in which the people have gone to the filling station to get petrol and then to get kerosene, that is the word kerosene, and they put it in their stove. I know now the stoves are kerosene stove are fast like degenerating. We are fast losing them. We are not seeing them, but there have been cases, and they went to the filling station to get the kerosene, and by the time they got home, they put it in their lantern or in their stove, and by the time they put it on, it lighted because it was not purified. There was no clear separation between your petrol and your kerosene. So it has not been purified, and that's why you have such incidents happening. So the final stage of crude oil refining involves treating. You treat them and you blend the different fractions obtained from the various stages to improve their quality and meet specific product requirements. So if I'm having my kerosene, it is pure kerosene. If I'm having my petroleum, it is pure petroleum. That is your gasoline. If I'm having my gas, it is pure gas. If I'm having lubricating oil, it is pure lubricating oil. If I'm having my diesel, it is pure diesel. And if I'm having my bitumen, that's my asphalt, it is pure asphalt. There's no other product attached to it. So we're going to look at this process. It involves two processes. We're going to look at it very quickly. The first is desulfurization. There's some processes involved, under this purification. So you have desulfurization. So many crude oil fractions contain sulfur compounds, even after you've gotten them at that specific boiling point. Some of them contain sulfur compounds which need to be removed to reduce pollution. The desulfurization process removes sulfur, resulting in cleaner fuels. So when you remove the sulfur, you have a more cleaner fuels to use. Then the next is catalytic reforming. This process uses catalysts to improve the quality of gasoline by enhancing its octane rating and reducing the content of undesirable compounds. So what you use to check if an oil is pure or not is the octane rating. There's a way to check it. So this catalytic reforming helps to enhance its octane rating and also to reduce the content of undesirable compound. And all these undesirable compounds are impurities. There are impurities in those oils or in those products. So the next is your blending. We have looked at your desulfurization. We looked at the one we just moved out now, and now we are at blending. That is, refineries blend different fractions in specific proportions to create various products such as gasoline, diesel, jet fuel, and other specific fuels. The blending process ensures that the final products meet the required specification and performance standards. So this blending process, all it does is to ensure that what we are having as our final products, after we have passed them through cracking and conversion, that is cracking and the rest, and we are moved into purification, blend under this blending now, it ensures that the final products, the one that will be taken out for commercial purposes to be sold to other people, it meets the required specifications and the standards of the organization controlling them and performance standard of those organizations. So very quickly, we have looked at the three major steps of refining crude oil. And we asked that, is it important? Why do we refine crude oil? Should we refine it? And I know by now you can answer, even from the one I gave just now, in the course of explanation, like people having explosion in the process of lighting a kerosene stove or a kerosene lantern. So the impurities, the contaminants, petrol contaminating those kerosene has made them what? Impure. Yes, they are both fuel, but it has made them impure. So you have to purify, you have to refine your crude oil to give you the specific product you want in the market to avoid some accident and other things that might come along with it if they are not being refined. So I asked the question, I said in our objective, I didn't ask the question actually, I mean to say that I said, is it that you just see, because you see a pipeline passing through your backyard, you just feel like, okay, let me tap from it and then refine? No, there are some multinational companies that are involved in crude oil refining. There are some multinational companies, so not just anyone can just stand up in a day, wake up one morning and decide to refine crude oil. There are some multinational companies involved in crude oil refining, and one of them is ExxonMobil. You might have been seeing this logo here that we have in a picture here. ExxonMobil is one of the largest publicly, it's not private though, it's publicly traded multinational oil and gas companies engaged in exploration, in production, in refining and marketing of petroleum products. So they don't only just market petroleum products, they explore, they produce. And in the exploration process, we're talking about getting extraction, then getting it refined to the refinery, then you refining them, and also producing them, refining and marketing of petroleum products. Another company we have is Royal Dutch Shell. Royal Dutch Shell is a global energy company involved in various aspects of the oil industry, including crude oil refining and the production of fuels, lubricants, and petrochemicals. Another one we have is Chevron Corporation, an integrated energy company with operations in exploration, in production, refining, and marketing of crude oil and petroleum products. So Chevron is another company. We have looked at ExxonMobil, and now we have Chevron. We have also looked at Royal Dutch Shell. The next is BP, that is British Petroleum, is a multinational oil and gas company engaged in exploration, production, refining, and distribution of energy products. And the last we have here, not the least, you can still search out other multinational companies. There are a lot of them that are engaged in this. So, but the last we have here, not the least, is Total Energies, a French multinational energy company involved in all aspects of the oil. So they are involved from drilling. So if you were in if you've seen the previous class when we talked about the formation and also the exploration and the extraction, we talked about you first get a geological survey. That means you survey the place where it is to know where you can actually get the oil from, and down to the exploration, that is you drill it out, get it, and you transport it to the refinery, which is being refined. So Total Energy, they are involved, is a company that are involved in all the aspects, all the stages of the oil and gas industry, including refining, marketing, and distribution of petroleum products. So very quickly, we're going to look at the ExamGuide app to check out ourselves to know if we have learned something else, if we can remember what we have learned. Do not forget that the question, the topic is crude oil and the subject is basic science. So you select the topic of interest, which is crude oil. And on the year, you just click random. So I'm not specifying a particular year. I'm randomly checking out questions. So you get started. Wow. And the first question we have here is, the 3 stages involved in refining crude oil are A, separation, conversion, and purification. B, conversion, separation, and purification. C, purification, conversion, and separation. D, conversion, purification, and separation. E, separation, purification, and conversion. So it is not just enough for you to just know that it's 3 stages are this. You should be able to know what order they come, because what I'm saying in this question is they are checking, okay, in what order do you refine crude oil? That is it. These 3 stages involved. In what order do they come? Is it separation, conversion, and purification? Is it, do you convert it first? You now separate and you now purify. Do you purify first? Do you now convert? And so that's the question, what is all about. So if you're going to go quickly down memory lane, you're going to know that the first one we talked about was separation, where I specifically mentioned distillation, that is distillation. And the method used is fractional distillation, where we pass through our crude oil through the fractionating column. And each of those gases, or each of those hydrocarbons are deposited based on those contents, based on their boiling point. That is how you get them. So the first one is separation. Then the next is conversion. Under the conversion, we have cracking and reforming. If you can remember, cracking and reforming, and followed by your purification, treating and blending. So the right option there is option A, separation, conversion, and purification. We have a question here. It says, refining of crude oil is carried out by the following multinational companies, except, you know, I told us that I just gave us those ones that are still a lot of multinational companies that are involved in refining crude oil, and you can carry out research on them. So we're going to look at some of these. A, Chevron. I mentioned Chevron. Chevron is one of the multinational company that is involved in the refining of crude oil. ELF, we have Ajib, we have Texaco, and we have Total. And I mentioned Total too. Total is one of the multinational company involved in the refining of crude oil. So the right answer is Ajib. It's not a multinational company, it's a subsidiary of ENI. So Ajib is not is the right answer. It's not a multinational company that carries out refining the refining of crude oil. It's just a subsidiary of a multinational company that carries out the refining of crude oil. So the right answer is Ajib. So you click on Ajib. Okay, so I'm going to take this question, and after this question, I will allow you to go through others by yourself and try to check yourself if you can answer those questions. It says the following are products of fractional distillation of crude oil, except, if you can just wind your mind back to those pictures that was being displayed and the various constituents, various contents that were collected at various stages based on their boiling point, to be able to get which is not a product of fractional distillation. We have A, kerosene. Kerosene, is it on the column? Yes. We have B, petrol. Petrol, yes. Gasoline is one of it. Bitumen, we're talking about bitumen, and we're talking about asphalt. Yes, it's even at the lowest part of it, and I say you can get it at greater than at a degree of 600 degrees centigrade and above. Your lubricating oil, yes, you can. And E, coal gas. So the only one not found on the fractional distillation and fractional Fractionating column is your cold gas. So the right answer is E. So you can get it in your fractional distillation. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives detailed explanations of all the questions at the end of your practice test. You can also learn a particular topic of interest with different modes like study modes, mock modes, and practice modes. It has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Do not forget to subscribe to our channel and hit the notification bell and share the video with others that will benefit from it. Bye for now.